Hi there, we're going to do a couple of starters and then get on with finding the areas of triangles which are not right angled today. So first of all, one paper clip weighs 0.14 grams, find the weight of 1,000 paper clips. So remember, what I want you to do with these starters is, if you know what you're doing, just pause the video, answer the questions and then skip forward to where I'm giving you the answers. Okay, so if we've got the weight of one paper clip, then we need to multiply that by 1,000. So 0.14, we're going to multiply that by 1,000. And of course, 1,000 has 1, 2, 3 zeros. So we need to move all our digits 3 places to the left. So moving 1 place, the 1 would be here. 2 places, the 1 would be there. And 3 places, the 1 would be there. Now remember, the decimal point stays where it is the whole time. It's the digits that move. The 4 has to follow the 1. And if we've got any spaces between the digits and the decimal point, we've got to fill them in with zeros. So the answer is 140 grams. And we don't need the decimal point there because it comes after all the digits. Okay, next question. Special bulk offer. 500 tea bags for £15. Find the cost of 1 tea bag. Okay, so the cost for 500 tea bags is £15, and we need to divide that by 500 because we want to find the cost of 1 tea bag. Now that seems a bit of a strange calculation to be doing, I think. Remember, 15 divided by 500. If you're dividing by 500, what that means is you have to divide by 5 and you have to divide by 100. Okay? So we can do the first bit, first of all, can't we? 15 divided by 5 is 3. So actually what we're doing is 3 divided by 100. And remember, the decimal point in 3 is there. If we move, we've got to move 2 places to the right because we need to make our number smaller because we're dividing by 100. So 2 places. So the first place, 3 would go here. Remember, the decimal point stays where it is. If you move it 2 places, the 3 goes here, and you're going to need a 0 in there. Whenever you've got nothing in front of a point, you put a 0 in. Remember, our original price was £15, so this is also in pounds. So the answer is, it costs 3 pence or £0.03 per tea bag. Okay, so as I said, today we're looking at areas of non-right-angled triangles. So, first of all, a little recap was when we were looking at right-angled triangles yesterday, so for example, this right-angled triangle here. If we made it into a rectangle and then halved the area, then we had the formula A equals a half B times H, because we talked about the base and height of a triangle rather than the length and breadth. So a rectangle has a length and a breadth, but a triangle has a base and a height. Okay, and it's clear to see, if I just go around this actually, you should get a better picture now. So that's obviously not been done as neatly as the original diagram. But if I just pick that up now, see, I can move that. If I turn that round, we can see that it is the same as that triangle there. Okay, so those 2 triangles are the same shape and size, and we can see that quite clearly. Okay, but when we look at our next diagram of a triangle, well, where would we draw the rectangle here? Because we haven't got a right angle in our triangle to make an easy rectangle, have we? So have a think about that for a moment. How could you draw a rectangle? Well, if we just, now excuse me doing this, actually I'll just grab my ruler. It's not ideal drawing with a ruler on here because it does make a bit of a clattery sound, but I'll do my best to keep it quiet, and I'll switch to a different colour so we can see what we're doing. So if we drew our rectangle here, then we can see, hopefully, oops, there we go. So we've drawn our rectangle round there, and now if I draw one other line in that rectangle, down there, then we can see that we've got two rectangles now. We've got this one and this one. And in this rectangle, if I do what I was doing earlier, if we have a look here, if we just briefly colour in this triangle, then we will be able to see, just like in the first one, just carefully go around this now to cut it out. Right, we can see this triangle here. If we turn it round, we can pop it back there because it's exactly the same size and shape as that one. So what we've found there is that the red triangle that I've coloured in there is the same size and shape as this one here. So if we were only to consider this rectangle, then the triangle would be half of it. Okay, the same is the case for this rectangle here. I'm not going to demonstrate that because we can see it. Okay, so if I just coloured in this here, then what we can see is that overall, the red scribbly triangle that I've just coloured in is the same size as the two white triangles that we've got here. Okay, and remember, I can show that because we could colour this one in a different colour and turn it round and it would be the same size as this one. And then we could colour this one in a different colour, turn it round, and it would be the same size as that one. Okay, so this formula of a half base times height still works because this is the base of the triangle and that is the height of the triangle. But remember, the base and height have to make a right angle, okay? Remember what we said about measuring your height? You do it from the top of your head down to the ground. You don't do it from over there somewhere. That doesn't work, okay? So this is the base and this is the height. And therefore we need to be careful when we're finding the area of a triangle that we're not using this line or this line as the height. It's got to be the height that makes a right angle with the base, and that would be that line down there. So it doesn't matter if the height is drawn at the side like this, or in the triangle, or at the other side. It doesn't matter where, as long as it makes a right angle with the base. Okay, so this area formula that we had before is still the one that we're going to be using. Okay, so here we can just see a more neat diagram of what I've just shown you. So what we've got basically is that these two green triangles are the same size and shape as the two lilac triangles. Therefore, this purple triangle here takes up exactly the same space as the rest of the rectangle if you put them together. Okay, because this one's the same as this one and this one's the same as this one. So the area is a half of the base times the height. Okay, so remember though, height has to be at right angles to base. This is not the height and this is not the height. Okay, right, so we've just actually talked about this, so let's just make sure we're okay. So in this diagram here where we've got a yellow triangle and our formula, then which measurement are we using for height? We've got quite a few to choose from there. We've got this one, this one, this one, or this one. So which one's the height? And the answer is that one's the height, or that one's the height. This is not the height, and that is not the height. We could have the line drawn in there as well, which could be the height because it's the same size as those other purple lines that I just drew. Okay, So we're going to use that formula to find the area of each triangle now. So remember what I've taught you before. Each time you're going to use a formula, you should write it down. Okay, every single time. Get into the habit of doing that. So we need a half, and remember we can write times here because times means of in maths. So the base we can see is 15 centimetres. But the height, we've got a choice here. We've got 10, 8 or 12. Which one is the height of that triangle? Well, there's only one of those lines that makes a right angle with the base, and it's this one. So it's 8 for the height. Okay, and remember, when you're doing this multiplication here, it doesn't matter what order you do it in. Okay, I think the easiest way to do this one is a half of 8, which is 4, and then times it by 15. So 15 times 4, or 4 times 15, doesn't matter which way round. So if you double 15, you get 30, and then double that makes 60. So it'd be square centimetres. Okay, so remember, if it's area, you need square units. And the units should match the measurements that you were given, but they should be square units. Okay, next one. Again, it's a triangle, so we're going to write down the formula. A equals a half base times height. So let's see if we can identify the base and the height here. Well, we're only given 2 measurements this time, aren't we? So the base will be the 20. And the height there is the same as it's there, and it's 12. Okay, so this time I think we can just do this bit first and then times the answer by 12. So a half times 20, remember, means a half of 20. So that's 10 times 12. So it's 120. And look at the units. They're millimetres. So these are square millimetres. Okay, you must always check that you've got the correct units and that if it's area, they are squared units. Okay, now this works even if you can't draw the height of the triangle within the triangle. So for example, the ones that we looked at before, where you had ones like this, you could draw the height inside the triangle. But some of them you can't do that. So like the one we've got here, if we draw, wherever we draw the height, you're not going to get it entirely within the triangle. But that's okay, it doesn't matter. Okay, as long as the height makes a right angle with the base, then that's fine. So we're going to use our normal formula. A equals a half base times height. And the base is 4.5 centimetres. So all you need to do for your base and height is make sure your 2 lines are at right angles to each other. It doesn't matter if they don't touch, as long as if you extend them, they would make a right angle. Okay, so the base is 4.5 and the height, well, the only line that is at right angles to this baseline here is the 4 centimetre line. Okay, so we're going to work this out, and I think the easiest way to do this one is probably a half times 4, or a half of 4, so that's 2 times 4.5, or 4.5. What's 2 times 4.5? And 2 4s are 8, 2 halves are 1, so that's 9 altogether. We've got centimetres for our units here, so we need square centimetres for our units in our answer. Okay, next one. So our next question, well, we can see it's a triangle, so we know we're going to need half base times height for the area. And then we need to just make sure we're picking out the right numbers for the base and height, and they need to be at right angles to each other. So it's this triangle, it kind of looks a bit upside down, doesn't it? If we're talking about the base and height, whoops, missed there, never mind. But we can see if we turn that the other way up, Then the base is the 12 metre line, and the height is this 4 metre line here. Okay, so it's a half times 12 times 4. The 8 and the 7 are not needed for this question because neither of those are at right angles to the base. Okay, so it doesn't matter which way up your triangle is. All right, so we need a half of 12 times 4. Well, this time let's do it 12 times 4 and then half the answer. So 12 fours, do you know that? Remember when you times them by 4, you can double it and double it again. So you'd get 24 and then 48. So we want a half of 48. So that'll be 24. And we've got metres here. So we'll have square metres in our answer for area. Okay, and then the last one that we're going to do today is this one. That again, we've got a sort of tilty one, but all we need to be looking for, we can see it's a triangle, so we know its area is a half base times height. And we just need to work out which the base and height are. And basically what we need is a side of the triangle. So we've got that 10 there. And the height has to be at right angles to it. So that 11 centimetre line there is at right angles. So we need to do a half times 10 times 11. So I think the easiest way this time is to do the half of 10, which is 5 times 11. And remember, the 11 times table is a nice one where the digits are repeated up to 9 times 11. Sorry, my phone started ringing then. So we just need to put our units on the end of this, don't we? So these are centimetres, so our area would be square centimetres. So that's us all done for area of any triangle. So it doesn't matter if our triangle is right angled or not. The thing that we've got to bear in mind that's very important with our triangles is that our base and our height must be at right angles to each other. So if our triangle looks like this, that's fine, because this would be the base and this would be the height. But if our triangle looks like this, then our base would be all the way along here, but this would still be the height because it's at right angles to the base. Okay, so have a go at those practice questions, and tomorrow we'll be getting on with some more area work. See you later.